Hey everyone, so for assignment 3, problem number 1, we're looking at simple color 3D shader and we're fixing the shader constants to separate the camera matrices from the world matrix. And so I created a new structure for the world matrix. I separated M world from the matrix, the world matrix from the other matrices for the camera. And I called it in its own struct and created its own buffer. And then in simple color 3D, I created a constant buffer called cam buffer and assigned it to register B0 with the two view and projection matrices. And then created a constant buffer called world buffer and register B1 for the world matrix. And then when I'm creating the buffers, I create both of the constant buffers for the camera matrices in the world matrix, and then when I'm connecting them, I'm assigning a 0 for the camera matrices and a 1 for the world matrix because I assign B0 and B1 respectively to those. And then when I'm drawing them, I'm doing them separately. So I do the camera matrices first, and then I do the world matrix next. So if we run this, you see that it works. So for problem 2, I have to create the unit pyramid and create with the height of 1, height, width, and length of 1. So here I create a model pointer in DXApp called pmodel1, and then I use one of the constructors to create the model, the unit pyramid, and here I take the number of verts and create the vertices and create the indices and do them correctly, and then if this all works out, you get the unit pyramid, and this is in wireframe. I'll change it back to solid. And then that's in solid now. And I had to also make sure that I deleted it in my destructor model. And then for problem 3, use model class and create 3 pre-made models on the same screen with each with a different color. So for that, I had added a different I modified the constructor so that in model CPP it takes a shift X, a shift Y, and a shift Z, and that shifts the object from the center by however much. And I added the shifts to each of the vertices when I'm creating the vertices in the respective either the pyramid or the unit box. And so if I run this, back in DXApp, I create 3 models, and then when I draw them, I'm using the shader, and then I'm drawing them, the first one, and then I render it, and then I do the second one. I didn't really have to define world again because it was already using the same world, yeah, and then changing the color, and then do object 3, the same thing, and render it again. And then with that, I get this, the 3 objects. And then for problem 4, I had to do the same thing, but instead I had to do 4, and then 2 were made with collector selected 3D shader, and 2 were made with simple color 3D shader. So problem 4. I created actually a class, and I know this was part of the further work, but I didn't really realize it, and so I created my own shader class. So this is the header file, and it takes a vertex shader and a pointer to a pixel shader, and then it takes the blobs, takes the file name, takes the device, takes the vertex layout, and so then these are the private functions. It creates the vertex shader, creates the pixel shader, compiles the vertex shader, compiles the pixel shader, and creates the input layout. And then I took this that we had from dx app.cpp and I put it inside here because I thought it was appropriate. And then these are the default. This is the default this is the constructor, and so as you can see, this is all done in shader.cpp. And so then I create the models too. So yeah, when I create the shaders, I'm defining which file I'm using, and then I create the 4 models. Then I go down, and then I create the buffers too. I could have added these buffers, constant buffers, into the shader, and I think I will do that later on, to add the creation of the constant buffers for each of the shaders into the shader.cpp file. So I create the constant buffers for the color selected 3D only, and then the simple color 3D, and then I obviously I don't define them yet. In the draw scene, I'm creating the camera data, and then over here I'm setting the shader, the input layout, and the constant buffers, and I do those appropriately, and then I create the 2 objects that use those shaders, and then I reset the input layout and then the 2 constant buffers, and then I draw the other 2 objects. And then when I do that, I get 2 objects that use simple color and 2 objects that use color selected 3D, and they're at different positions. And that was number 4. Number 5, we had to create a unit sphere, and it had a radius of 1, and it takes a V slice and an H slice. So in problem 5, and this was all a lot of trial and error, but the book really helped out a lot. So I created the model using the unit sphere, and I added 2 extra parameters, the H slice and the V slice, and then as you can see, and these are set by default equal to 0, but you can define them, and then once you define them, it takes those, the V slice and the H slice, and it goes to model tools. Then it creates, it defines the number of vertices, and then the array for the vertices, and then the number of triangles in the array for the triangles, and it creates the vertex buffer. And then we're defining 2 angles. One of the angles like the height of where each vertex will be, and then the other angle is like where the vertex will be along that height, like so. And I defined it basically. There's a top vertex, and then there's a bottom vertex, and then there's the inner vertices. And so there's a top hemisphere, the inner slices, and then the bottom hemisphere. So I'm defining the top vertex here, and then for every slice I'm defining the inner vertices, and then I'm defining the bottom vertex, and then for the indices, defining the top hemisphere for the top triangles, and then for the inner slices. This was a lot of trial and error. Started slow and then just went up in terms of size, and then the bottom hemisphere, and then yeah, and then when I run this, you see it creates a sphere with 12 vertical slices and 12 horizontal slices, and obviously I can change that, but before I do it, and here I am in the draw scene. I'm rendering the sphere, and let me just change it just to show that it's dynamically changing. So if I change this to 5 and this to 5, and now you see it's a sphere with 5 vertical slices, 5 horizontal slices. I could change this separately, so I could make this 12 and this 5. I think the first one was the horizontal slice, yeah. So if I run this, you can see that now there's 12 vertical slices and 5 horizontal slices. So yeah, that's just playing around with it, and again I can change it from being in wireframe to just show that it's a solid. I will do that. I'm just going to change this back to 12 to make it look nice and pretty. And there is our sphere. So that was number 5. And then in terms of the further work, the advantage of not having two model objects holding the same data is that you can change the properties of both objects by only changing it once in one of the objects. So that's really good if you have similar objects that you want to behave the same way. And then I showed you in problem 4 my shader header file. And the only thing that I would probably add is the constant buffer creation within the shader class, so that all can be done in one fell swoop. Okay, I think that is everything for this assignment. Okay then.